Welcome. Today we will be starting a new topic, that is ground segment. We have already discussed about the orbit, then the space segment, and then the link budget, then the propagation channel through which the signal is coming through, and today we will start on the earth, that is on the ground segment. So, what we will cover on the ground segment? We will cover the types of ground segment, and since it is on the earth, not always on the ground. So, we will call earth station, that is the terminology people use, earth station. And then of course, the subsystems, inside the earth station, and the types of antennas used in the earth station. That is very important point, we will see. And of course, there is the measurement technique of two important parameters of the earth station we know already, which is the receive characteristics, that is G by T, and the transmit characteristics, which is EIRP. So, these are the major topics. Inside that we will see what else we will understand inside. I will take another pen. So, the ground segment we call earth station or earth terminal, which is very near to earth, may not be always touching the earth. So, it could be on the ground, it could be on ground surface, or it could be mobile on the ground surface, it could be mobile on the ground, or it could be mobile on the ocean, marine or maritime, it could be mobile on the air, could be mobile on another satellite. So, and then these type of mobile things can be a very small station, which you can call handheld, just like our cell phone. There is another type of ground mobile which is there, which is recently being investigated and certain standards have come. It has not come in the textbook yet, which is railway mobile. Railway mobile. And then another type of mobile which is not, which is mobile, which is called transportable. Or a simply portable. These two types are the type of earth stations or earth terminal. When you are moving, that time you are not communicating. That means you move, stop, and then point to the satellite and communicate. So, there are fixed type of earth terminal, that is could be on the ground, which is fixed, and could be mobile, which could be on the ground, that is on a vehicle. It can be on a road, it can be on railway, it can be on boats or ships, which is maritime, it could be on air. Well, walking you can talk, that is handheld. And there are two other types of pseudo mobile things available, which is called transportable or portable. That means you carry the terminal to a place and then stop where the event is occurring or where you want to communicate, and then point your antenna to the satellite and communicate. So, the different types of packaging is done, different type of environment. When you are handheld or portable, package is very small. When you are on the ground, package may be large. When you are on the railway, packaging is different. So, there are different types of packaging. There are other groupings possible. Which I can say how it is communicating based on that other type of grouping. That means, say, let us say you are trying to receive only, which is very common. You have seen that the TV broadcast, what we receive in our television, it's coming directly from satellite, and many people in cities and villages, they are using a direct satellite receiver, which is called direct to home, DTH, direct to home. This is a fixed terminal, may be mounted on the window, on the rooftop. So, this while moving you are not using direct to home, but this is direct to home, home is not moving. So, therefore, it is a fixed station, but this is receive only. Through this DTH you do not do a two-way communication, you receive only. There are some programs goes on in TV where interacting with the studio is taking place from a person, and studio things are getting broadcasted, the events happening in the studio. Those interactions are done in telephone mode, not through DTH, through other means of communication, may not be always through satellite. So, DTH is receive only. There could be something like I should say, you are not very familiar, it is called reporting, or we can call automatic weather station or data collection platform. You can understand from the names, automatic weather station at different locations, it may be inhabited or need not be inhabited. They say Himalayan places where the glacier has to be monitored, or somewhere in the desert you are measuring some temperature, somewhere in a sea you are measuring some other parameters, or simply in different villages by our meteorological department, they have placed many such terminal which automatically measure pressure, temperature, relative humidity, wind speed, wind direction, many other parameters. So, they are collected and reported to a central station, maybe at India Meteorological Department building at New Delhi. So, these terminals are AWS or data collection platform, automatic weather station or data collection. It is one way, it is transmit only, some form of reporting the data, and generally other things which are there, that is our VSAT, very small aperture terminal, which is there in our ATM, bank ATMs, very near to bank ATMs I have mentioned earlier. So, this VSAT is very common, which is transmit and receive both way, it transmits and receives. Similarly, the corresponding to VSAT larger stations are there, which are hub, which are also transmit and receive. So, depending on the type of transmission, whether receive only, transmit receive, or transmit only, the other types of grouping can be made. Of course, that also will change the characteristics and the sizing of the station. If it is a receive only station DTH, there is no transmit chain. So, half of the electronics is not there, the power amplifier is not there, up converter is not there, there is no uplink, it is receive only, whereas in the transmit only the receive chain is missing. So, definitely the electronics is much simpler, and transmit receive system has full ability to communicate. So, both transmit chain and receive chain is there. So, accordingly the sizing of the station, its power capability, the antenna sizing, the number of bits it is carrying, all these things will be varying. So, based on various ways you can define the ground station, either in which environment and for what purpose it is being used, and which way it is communicating, that way. Okay, let us go into a little more inside the station, that is the electronics in the station. Obviously there is antenna, so let us call there is a receive antenna, and then this receive antenna will go into the RF section. So first will be low noise amplifier, we have discussed earlier. Then there are down conversion, or combination of these two are called low noise block converter, LNB is another terminology they are using. Now after conversion you are in IF. So at the IF level you do demodulation. So I will simply call modem, and of course there will be certain error correction. So there will be codec, that is for error channel error correction. Then if there are multiple people are using, so there could be multiple access control, and then after getting all the bits, then it has to be whether if it was baseband compressed or decompressed, like in TV it is done, in voice it is done. So there are other types of codec, which is the baseband coding and decoding, which is compression and decompression takes place. And then there may be multiplexer, demultiplexer, there may be switches, and the interface to the user, and it goes to the user terminal. It can be a TV, it can be simply a speaker, it can be a computer terminal, it can be a storage of a computer, or it can be connected to a LAN. So similarly in the transmit side you have the other part, that is the switches which are coming and then interfacing to the user, and then you have this modulation, the coding, multiple access control, etc. So this side I can call baseband side, and this side after this modulation you have the up converter and then power amplifier. In some cases it is high power amplifier, depending on how much power you are transmitting. So these are sometimes combined, like LNA and down converter is combined, called LNB. Here it is called block up converter, BUC is another terminology, and then it goes to transmit antenna. If we keep this antenna part separate, though it is falling under RF, we call this is the RF part, and this is I can call IF and baseband. If we come down to intermediate frequency, or directly it can be demodulated. So there we have the antenna, and some of the cases the for geosynchronous satellite it may not be always required, but for other positions of the satellite, or if you want to change from your operation from one satellite to another satellite, you may have to move the antenna. So there may be having some arrangement for tracking. In some of the station this tracking is important, you track that, and if it is a low Earth orbit satellite, definitely you may have to track the antenna depending on what type of gain in the antenna is used. So the antenna is a separate part, RF is a separate part, and IF and baseband is separate part, and then it goes to the user devices. Now this sizing of the earth station depends on sizing of earth station is based, I can call it a large station or small station, based on the antenna size and the power amplifier size. Because if I have to transmit a larger power, the power amplifier is a dominating unit out of all these things, it draws heavy current, and all other things are electronically nowadays realized in a very small area and small packages are used, particularly these IFN baseband nowadays are people are using processors DSP, and sometimes depending on different application or capacity they may use FPGA, ASICs, people use different forms, but these are processor side. Using processors you can do all these things, and here the RF part you have to use separate. Nowadays even people are trying, but RF ICs have started coming in, but we can, for the timing, you can assume that they are having separate transistors. In power amplifier you will have sometimes higher power required, then you go to tubes, its TWTAs are used. So, and then the antenna. Now we will spend some time on the sizing of the antenna and how we come to that. Let us go back to our original transmission equation, that is C by N naught in dB is EIRP plus G by T minus the losses, majority is the loss in the path, minus the Boltzmann constant. This is in dB. Now this form of equation is true for uplink and downlink. So when you are on the uplink from the ground station, that is from earth to space when you are going, then the C by N naught uplink will be depending on EIRP of the earth station. What is EIRP? This is nothing but PT into GT, that power amplifier output including the feeder loss and then the gain of the transmitting antenna. This GT is gain of the transmitting antenna, and in case of uplink this G by T is for the satellite and uplink path loss and K. Similarly, for the downlink this EIRP is the EIRP from the satellite, and this G by T is G by T of the ground station. Now you see in both uplink and downlink the satellite as well as ground station have antennas that is being used. Now satellite antenna, whether it is transmitting or receiving, you cannot make it very large. Normally there are two reasons. One is a very large antenna, if you try to deploy, obviously the weight will be more, so your launch cost is more, is much more complex. So therefore at this type of frequency like 10 gigahertz or 3 gigahertz and above, people are using a smaller, relatively smaller antenna, of the dimension of about a meter and a half diameter, like that. And then another reason is there, depending on what type of business your satellite provider is doing. Say so all over India it has to be covered. So for all over India, if you want to cover with a one single beam, then the gain will be relatively less, instead of focusing a beam over a particular region of India. So therefore if the gain is less, antenna diameter will be smaller. So for depending on the service requirement as well as the cost requirement, the satellite antennas are selected, and generally it is of the order of 1.1 meter to 1.5 meter, maximum 2 meter at these micro frequencies. Since the satellite antenna is gains both in transmit and receive is relatively smaller, so it becomes critical for the ground antenna, because the when you are having a G by T of the satellite, this G is the satellite antenna gain, which let us say it is relatively lower. So the ground antenna EIRP, ground terminal EIRP, which includes the ground antenna GT, its gain has to be high. Similarly, when it is receiving, the gain of the ground antenna has to be higher to have a better G by T. So the antenna gain is important factor for a station sizing. Now generally it has been seen when we do the link calculation, we have done some of the link calculation, and we have seen of the order of gain of the order of 30 dB or more are required. So, at this type of frequency of operation 30 dB or more, you need parabolic reflector antenna. It can be realized with array antenna or many other combination, but cost wise and handling wise it has become popular. So, parabolic reflector antenna. So, wherever we are drawing the sketches, you might have seen we are drawing a small parabola. So, for satellite communication parabolic antenna is very very popular antenna, but that does not mean that smaller antennas cannot be used, like mobile satellite phones or portable phones, portable satellite terminals. They have a smaller gain of the order of let us say of the order of it will be much smaller, of the order of 15 dB or 20 dB or even sometimes much smaller than that. Now, for this purpose the satellite antenna gain has to be high. So, therefore, if you remember in our introductory class, I have shown some of the pictures of the large antenna deployed system of the order of 12 meter to 15 meter dia antenna by Inmarsat, Thuraya. There are a couple of pictures that were shown. So, those are very large antenna, very special purpose, mainly to provide the service to ground system which has very small antenna gain. But generally we are talking about DTH and VSAT, where the for the terminal, say let us say DTH, antenna gain is much lower, of the order of let us say 20 to 30 dB. So, the sizing is 50 centimeter to 1 meter, sometimes lower than 50 centimeters is available. For the other group, that is VSAT, very small aperture terminal, the antenna gain is of the order of 30 dB or greater than 30 dB. So, of course, there are other antennas which are used by AWS and DCP. They do not use parabola, they use array of dipole or helix or sometime patch, microstrip patch array. For sat phone mobiles, use simply patch antenna, single patch sometimes is used. So, these are the different type of small antennas and sizing of the antenna that comes because of our C by N relation, where the antenna gain is a important factor. Now, let us look at the larger station antenna. Now, we remember this relation, gain is 4 pi d by lambda square, where d is diameter of parabolic antenna and lambda is wavelength for that particular frequency of operation. That means, you can say it is proportional to d by lambda whole square. Then there is something which is the beam width, we call theta 3 dB, that is 3 dB beam width, which approximately we stated that it is 75 lambda by d, or it is, I can say it is proportional to 1 by d by lambda. So, one interesting thing what we see, that that high gain antenna has larger d diameter and smaller beam width. And then one thing is important, the small beam, how it comes as an advantage, small beam that is smaller 3 dB has reduces the interference to adjacent satellite. Like you have the ground, on that you have a antenna and you have the geosynchronous arc on which you have a beam like this. So, your satellite slot, the orbital slot is this many degree, otherwise if you put another satellite it will start interfering if it is operating on the same bandwidth. Let us say another antenna is larger antenna, it is having a smaller beam width. So, the operating slot is smaller, this slot is larger. So, therefore, the beam width decides how much interference that can take place. So, there for this reason International Telecommunication Union has provide the antenna gain mask that has to be used, so that the number of satellites can be increased in this 360-degree arc. So, let us stop here, we will continue our discussion in the next period on this ground segment, particularly the ground segment antenna. Thank you.